So, hello everyone, welcome back to our session on Mechanics 1. So, today we'll be discussing about some problems coming under the section Pulley Systems. Okay, let's straight go into the problem section. Okay, so imagine that we have a ceiling right here onto which a pulley is connected. Okay, pulley connect ചെയ്തിട്ടുണ്ട് and ഈ പുള്ളിയിൽ കൂടെ there is a string going through it. Okay, ഇനി പോകുന്നുണ്ട് and the other end of the string, let's say മാസ് കുറഞ്ഞ ഒരു ബ്ലോക്കിനെ ഇവിടെ വെച്ചിട്ടുണ്ട്. Also there is another block, say with a mass m2. Okay, this has a mass m1 and this has m2. Yes, this is a connected line, of course. This is string. Okay, അപ്പൊ സ്ട്രിങ്ങിന്റെ രണ്ടറ്റത്തായിട്ട് രണ്ട് മാസുകൾ വെച്ചിട്ടുണ്ട് such that m2 is greater than m1. Okay, ആ സമയത്ത് we know that m2 will be going downwards and m1 will be going upwards, അല്ലെ, with a certain acceleration, say a. Okay, let's find out the acceleration. Let's find out the value for acceleration here. Okay, അതെങ്ങനെയാണ് നമ്മൾ ചെയ്യുന്നത്? ഫോഴ്സസ് കണ്ടുപിടിക്കണം, അല്ലെ, ഫ്രീ ബോഡി ഡയഗ്രാം വരയ്ക്കണം, ഫോഴ്സസ് കണ്ടുപിടിക്കണം, ഇക്വേറ്റ് ചെയ്യണം, ഫോഴ്സിനെ ഇക്വേറ്റ് ചെയ്യണം, നെറ്റ് ഫോഴ്സിനെ ഇക്വേറ്റ് ചെയ്യണം, അതിൻ്റെ അകത്ത് നമുക്ക് ആക്സലറേഷൻ കണ്ടുപിടിക്കാൻ പറ്റും, അല്ലെ. അപ്പോൾ ലെറ്റ് സി ഹൗ ദിസ് ക്യാൻ ബി ഡൺ. Let's draw the free body diagrams for each of the masses. Say m1 in the case lanangle, we know that there is m1g acting downwards, alle, and there of course will be a tension which is acting upwards, right, and there is an acceleration also that's also acting upwards. So m1g acting downwards, tension T in the string, and that is this one, tension T along the string away from the point of contact, and m1g in this direction, right? When we look at the second mass, we have m2g acting downwards and there is tension acting upwards, right? m2g, tension T, since it's the same string, tension value same ആയിരിക്കും since the string is massless, അല്ലേ? And we know that the body is accelerating downwards in this case. Okay, for acceleration direction we should always be taking it as the positive direction of force. Okay, അപ്പോൾ ആദ്യത്തെ കേസിലാണെങ്കിൽ ഇവിടെ നമ്മൾ നെറ്റ് ഫോഴ്സ് കണ്ടുപിടിക്കുന്ന സമയത്ത് it will be T minus m1g. That will be the net force in this case, whereas in this case we have m2g minus T as force net, and from Newton's second law force net is actually equal to mass into acceleration, right, since there is no change in mass, right? ഇപ്പൊ നമുക്ക് അതിനെ ഇങ്ങനെ എഴുതാം, T minus m1g is equal to m1a, and here m2g minus T is equal to m2a, right? So we can actually add these two equations. Let's write it down somewhere around here. So m1a is equal to T minus m1g, and m2a is equal to m2g minus T. If we are to add it, we know that this side will give us m1 plus m2 into a. The other side will give us m1 plus m2 into g. That is, the acceleration is obtained to be sorry, here there is a change. It will be m2g minus m1g. Yes, we are adding it, right? Sorry for that mistake. So this side will be m2g minus m1g, right? So acceleration will be m2 minus m1 into g divided by m1 plus m2. Okay, so this is how we find out the acceleration. And if we are to find out the tension, we can simply substitute the value of acceleration in either of these equations and find it out, right? So that's how this problem can be solved. So this is another similar problem which you can try at home. Okay. So let's discuss another problem. Say, as shown in this figure, we do 5 kg, say 5 kg block under, and here we have a 1 kg block, okay, which are connected by a string through a pulley. Okay. Upon ഇവിടെ we can see that the acceleration will be acting downwards, right? And it will be acting in this direction. For this block, it will be in this direction. Yeah. ഇവിടെ നമ്മൾ ചെയ്യേണ്ട first thing is to find out all the forces acting on the body, right? ഇവിടെ free body diagram വരക്കുകയാണെങ്കിൽ ഇപ്പോൾ 5 kg കാര്യത്തിലാണെങ്കിൽ we know that there is a force, there is mg acting downwards, there is normal reaction acting upwards, right? And which will be equal. From this figure it is not very clear, but yet both will be equal. And there is a force in this direction as well, right, which moves the body. അപ്പോൾ നമ്മൾ free body diagram വരയ്ക്കുകയാണെങ്കിൽ we have 5g acting downwards, n acting upwards, and then there will be a force that will be the tension, right? It is the tension along the string. Okay, so that we can note it as the tension T, right? And if we talk about the second body, we know that there will also be 1g acting downwards, and there will be tension acting upwards, and we know that the force is moving the body downwards, right? So there we have an acceleration acting downwards or a force acting downwards, right? So acceleration downwards, here in this case acceleration is acting in this direction, right? So here when you look at this picture, there is no vertical motion for this body, right? There is no vertical motion for the first body, the 5 kg one. It doesn't move up or down. Okay, all the motion it has is in the horizontal direction. So the force and the related motion is in the horizontal direction, which means that n is actually equal to 5g. Okay, they cancel out, and what remains as net force is this one, tension. This tension is equal to the net force, right? Or we can say m into a. From Newton's second law, it is m into a. M is 5 here, acceleration. Okay, and in this case, since tension is acting downwards, we take mg, that is m here is 1, so 1 into g minus t equal to 1 into a, right? That is g minus t equals a. So we have these two equations here. If you are to take these equations and combine it, what do we get? We can find out acceleration from this equation, right? Yeah, so that's how we do this problem. Now let's move on to do another set of problem from this section. അപ്പം ഈ കേസിൽ ഇവിടെ രണ്ട് ഫിക്സഡ് പുള്ളീസ് ഉണ്ടെന്ന് വിചാരിക്കാം. ഓക്കെ, say this is P1 and P2. This is P1 and this is P2. Okay, along which a string is moving. Okay, white color കാണിച്ചിരിക്കുന്ന string ആണ്. String ന്റെ രണ്ട് ends there are two masses connected. Say this is a 2 kg body and this one is a 5 kg one. Okay, ഇനി നമുക്ക് ഇതിനകത്തുള്ള ഫോഴ്സസ് നോക്കാം. ആക്സിലറേഷൻ ആണ് കാണേണ്ടത്. ഓക്കെ, എന്തായിരിക്കും ബോഡിയുടെ ആക്സിലറേഷൻ എന്നുള്ളതാണ് കാണേണ്ടത്. We know that there will be an acceleration acting downwards, right? ഈ കേസിൽ this body will be moving towards the left side, right? അപ്പം അവിടെ ഒരു acceleration will be there in the negative x direction and here there will be an acceleration in the negative y direction, right? അപ്പോൾ നമുക്ക് ഇതിനകത്തുള്ള ഫോഴ്സസ് ഒന്ന് നോക്കാം. Yeah, so in all of these cases there will be tension right here. It is lambum. There will be tension acting in this direction, right? And there will be tension acting in this direction as well, away from the point of contact along the string, right? And there will be tension acting in this direction as well. And all of these tension will have the same value since they're acting along the same string. And also that the string is considered to be massless, right? So let's look at the forces here. If we have to consider the first body, the 5 kg one, what we have is, let's not consider the vertical forces, let's only consider the horizontal forces. Then 5 kg one has a net force 5 into A, right? M into A. That will be equal to the tension. So we got the first equation. Now let's go and solve the second one. Here, there we will have to consider the downward force as well, right? അതാണ് ഇതിനെ move ചെയ്യിക്കുന്നത്. So in the second case, there is 2g acting downwards. Okay, that minus t will give us 2 into acceleration, right? So we have these two equations, and from these two we can find out acceleration, right? So 5a equals t, and from the second equation t is equal to 2g minus 2a, right? It's 2g minus 2a. So we can actually equate these two, which will give us the acceleration to be, acceleration will be equal to 2 by 7g, that much meter per second square, right? So that will be the acceleration with which this body is moving downwards, or this body is moving towards the left direction. Okay, so in this problem, two pulleys are connected here. One is connected to the ceiling and this is a fixed one. So this one is a fixed pulley and this one is actually a movable pulley. Okay, let's say there are two masses connected to these pulleys. This, let's say there is a 1 kg one, this is a 1 kg one, and this, let's say a 2 kg one. Okay, and let's see how the system works. Okay, say we are moving, that is the first pulley, let's call it as pulley A, and let's call this one as pulley B. Okay, so if pulley A moves upward by a distance x, that is, it's like say if pulley A moves to this position by a distance x, not only that this side of the string moves up, this side of the string also moves up, right? അപ്പം പുള്ളിയെ ഇങ്ങോട്ടേക്ക് മൂവ് ചെയ്യാന്ന് പറയുന്ന സമയത്ത് പുള്ളി will be placed somewhere around here, right? പുള്ളി നേരെ മേലോട്ടേക്ക് എത്തുന്നു. ആ സമയത്ത് we know that it is displaced, the string is displaced by a distance x here. അങ്ങനെയാണെങ്കിൽ ഈ സൈഡിലും അത് എക്സ് ഡിസ്റ്റൻസ് തന്നെ മുകളിലോട്ട് പോയിട്ടുണ്ടാവും. അതായത് ടോട്ടൽ അത് 2x മൂവ് ചെയ്യും. ആ സമയത്ത് what happens here is that this one actually gets displaced by 2x distance അല്ലെ. ഇവിടെ ഒരു സൈഡിൽ എക്സ് ഡിസ്റ്റൻസ് ആണ് മൂവ് ചെയ്യുന്നതെങ്കിൽ ഇവിടെ the total distance stringന്റെ length constant അല്ലേ. അപ്പോ it will move by a distance 2x, right? ഇതേ കേസ് തന്നെയാണ് സേ വെലോസിറ്റിന്റെ കേസിലാണെങ്കിലും it will be moving by a velocity 2v. ആക്സിലറേഷന്റെ കേസിലാണെങ്കിലും you will be getting 2a in this case. Okay, here you have to understand that if the pulley A moves by x distance up, the total distance in the string will be 2x, right? That is B will move down by 2x. Okay, I hope you get it. And we can actually write the equations from here. We have to find out both acceleration and tension here. First, let's see which are all the forces acting here. Okay, there will be tension acting in this direction upwards, right? Here also there will be a tension, right? ഇവിടെയാണെങ്കിൽ tension force will be acting upward in this direction, right? And ഇവിടെ weight ആണെങ്കിൽ 1g downwards. Here we know that it will be 2g downwards, right? ഇവിടെ നോക്കിക്കഴിഞ്ഞാൽ ഈ tension plus this tension, this will be, there will be 2t acting upwards. Okay, so when we look at these equations, these forces acting, we can frame certain equations from here. If you have to take the second system, here the acceleration is obviously acting downwards. Even upwards ആണ് നമുക്ക് എടുക്കാം. ആ സമയത്ത് 2g minus t, right? That will be equal to mass into acceleration, right? F net, which is equal to mass into acceleration. ഇവിടെ x ആണ് displaced ആവുന്നതെങ്കിൽ 2a will be the acceleration, right? ഇവിടെ x ആണ് displaced ആവുന്നതെങ്കിൽ ഇവിടെ 2x ആണ്. So 2a will be the acceleration. So m into m2 into 2a, that is 4a. 2g minus t will be equal to 4a in this case. രണ്ടാമത്തെ 1 kg ന്റെ കേസ് എടുക്കുന്ന സമയത്ത് 1 kg is actually moving upwards അല്ലേ. So there we can actually write 2t minus g equals m into a. M is 1, so that will be just a. So we have two equations here. If we are to take these equations together, 2g minus t equal to 4a and 2t minus g equal to a, right? അപ്പം ഇതിനെ ചെയ്യുന്ന സമയത്ത് you can actually multiply the first equation by 2. That will turn out to be 4g minus 2t will be equal to 8a, right? We are multiplying the first equation by 2. Okay. അപ്പോൾ അതിനെ എഴുതി കഴിയുമ്പോൾ ഈ രണ്ട് ഇക്വേഷൻസിനെ ആഡ് ചെയ്ത് കഴിയുമ്പോൾ what we obtain is 2t and 2t will be gone. That is 4g minus g, which will be 3g equal to 8a plus a will be 9a. That is, our acceleration will be equal to g by 3 meter per second square. Okay, so this is how we find out the acceleration. So it is with that acceleration, this pulley and this mass is going upwards, and the acceleration of this body will be 2 times that of this one. Here it's not just a, okay, the value is 2a here. Okay, you have to remember that. Okay, all right, so that is it about the problems from pulley section. Thank you for your patience. Thank you for listening and have a good day.